Öncelikle ilginize ve katılımınıza şimdiden teşekkür ederiz. Ben kısaca öncelikle firmamızla ilgili size biraz bilgi aktaracağım. Sonra konuyla ilgili sözü Trovaris AG kurucusu ve akademisyen Doktor Karşısına bırakacağım. Ve Muharrem Bey'in de size aktaracağı bilgiler olacak. Ufak birkaç ricam olacak. Mikrofonlarınızı kapalı tutarsanız şimdiden çok sağlıklı olacak. Sorularınız olursa bize yazarak iletebilirsiniz. Slide aralarında ve sonunda Muharrem Bey ve Karşısın bu soruları yanıtlıyor olacak. İyi webinarlar diliyorum şimdiden sizlere. Sesimle ilgili bir problem olursa da bildirebilirsiniz. Ses sıkıntısı olursa eğer. Ben şimdi başlıyorum. Öncelikle bizden biraz bahsetmek istiyorum size. Trovarit 2000 yılında Almanya'da Aachen'da RWTH Üniversitesi ve FAR Enstitüsü desteğiyle kurulmuş akademik altyapılı bir uluslararası danışmanlık firması. Yaptığımız iş bulunduğumuz ülkelerdeki yazılım pazarını analiz etmek. Almanya, Avusturya, Hollanda, Polonya, İsviçre ve Türkiye'de faaliyet gösteriyoruz. Herhangi bir yazılım ürünü satmıyoruz. Ancak olabildiğince çok yazılım firmasıyla temasta ortak çalışmalar yapıyoruz danışmanlık hizmeti kapsamı altında. İş ortaklarımız arasında biraz önce bahsettiğim FAR Enstitüsü, RWTH Üniversitesi, Supply Chain Competence Center gibi kuruluşlar var. Yine BDMA, Makine Mühendisleri Odası, Bilişim Teknolojileri Derneği, Bitkom gibi firmalarla hem know-how transferi hem trendlerin takibi gibi konularda çalışmalarımızı devam ettiriyoruz. Bunlarla ilgili çok vaktinizi almak istemiyorum. Olabildiğince çok sektörel fuarda, organizasyonda, etkinlikte, konuşmacı olarak, katılımcı olarak, ziyaretçi olarak yer alıyoruz. Ürünlerimizden bahsedecek olursam, Türkiye'de konumlandırdığımız 5 tane ürünümüz var. Bunlardan ilki roadmap dediğimiz bir firmanın mevcut durumunu ve kısa, orta, uzun vadede atması gereken adımları ortaya çıkaran bir yol haritası çalışması. Audit çalışmamız kullanılan yazılımların verimliliğini analiz eden bir çalışma. Select dediğimiz çalışma yeni bir yazılım yatırımı yapacaksanız eğer bunun ERP, MES, BI, PLM gibi yazılımlar olabilir. Hangisi olduğu önemli değil. Doğru yazılım ve doğru çözüm ortağıyla buluşmanız adına yapılan bir çalışma. Project ismindeki çalışmamız yazılım seçimini yaptıktan sonra canlıya geçiş sürecinde bağımsız bir göz olarak projenizi denetlediğimiz ve üst yönetime raporladığımız bir çalışma. En son 2017 yılında ikinci çeyrekte çıkan Ayben isimli bir ürünümüz var. Bu da Endüstri 4.0 yolunda yine gereksinim ve yol haritanızı ölçen ve raporlayan bir çalışma. Destekleyici çalışmalar olarak firmalarda kurumsal ana veri yönetimi, süreç danışmanlığı, yazılım uyarlama, altyapı denetimi ve sözleşme yönetimi yapıyoruz. Bunlarla ilgili biraz daha detay bilgi size yine Muharrem Bey aktaracak. Şimdi konuyla ilgili sözü ben Karsten'a bırakacağım. Karsten, have your say, please.
Yeah, thanks a lot, Ilja. So, good morning, everybody. I will take over control of the presentation. First of all, I'd like to greet you from Aachen, Germany, so some 2,500 kilometers northwest of Istanbul, more or less in the heart of a real big research cluster dedicated to the Industry 4.0 issue, which came up in Germany in the early 2010s. So I'm really happy to have the chance to just share some insights about Industry 4.0 with you in terms of like lessons learned in Germany. And I hope it will bring you some new insights. Maybe just a brief information to me. I'm the founder and CEO of 4.0 AG, responsible here, among other things, for the market research, which is a major part of 4.0's services to companies of any size and any industry who are working on their digitalization roadmap. So we screen the markets in terms of concepts, tools, services, what's going on in order to help these companies on their way towards digitalization. And of course, Industry 4.0 is one of the major motivations and activities in this digitalization initiative. And so what I like to do is give you a brief insight where we are here in Germany with the Industry 4.0 activities. So what do companies think about it? And then I may introduce some, let's say, typical characteristics of the Industry 4.0 concept. Quite often we get asked, what is it all about? Everybody's talking about it, but I really don't know what's behind it. So I may try to introduce this concept a little more in depth to you. Then I would like to just sketch some scenarios around actually here the ERP business software, which is in the most companies one of the major or core applications that have to cope with the Industry 4.0 concept. And I just would like to give you some very practical scenarios to provide some ideas how to implement, how it works, what effects come with Industry 4.0 solutions, etc. So then I would like to show how one can even say on a national level Industry 4.0 gets implemented in Germany, and finally give some conclusions and an outlook what the next steps might be on the national level, but and I think this is for you more important on the level of any company who is thinking about Industry 4.0. So now let's start. By the way, if there are questions, just feel free to ask. And I have to apologize that I'm not able to talk and to answer in Turkish, although I'm now coming to Turkey frequently for nearly 10 years. So in this case, I have to ask Morin Bey to translate, and I do my very best to answer your questions. So let's start. Where is Germany, the status quo in Germany when it comes to Industry 4.0? Let me show here a slide which represents, let's say, the relevance of Industry 4.0 in German industry. Industry means, in this case, all industries, the service industry, retail, and its manufacturing. And the figures are just representing a trend. We see on the one side, left side, the question for 2014, and the right side, the question for 2016. And when we asked, it's a big survey, we asked some 2,300 companies in 2014 about trends that are vital to them when they look to their business software, infrastructure, etc. The answer was that Industry 4.0 had no relevance at all when it came to those issues. It was at the end of the like 4%. 2 years later, already 16% of the companies said, okay, this is Industry 4.0 is an issue of major relevance to us, and that represents the biggest move forward for all of these issues. So, and that was in the time from 2014 to 2016. Next survey is on its way in 2018. Now we are starting it, so we are eager to see what this time the answer will be. But what one can say clearly is the Industry 4.0 plays an increasing role in companies, for example, when it comes to software deployment, the deployment of business software solutions, which, as I already pointed out, have to cope with the Industry 4.0 concept. So that means increasing relevance. If one looks back, where does it come from and where we are? You see on the left upper side the reason why companies really are eager to deal with Industry 4.0, why they are eager to understand the concept. There are promises or predictions made by well-known analysts. They say that German industry will really grow by the Industry 4.0 concept by some 65 or 67 billion euro until the year 2020. So a tremendous increase of economy just by that concept. Companies expect increase of productivity between 40 and 50 or 45 and 55% when it comes, for example, to technical professions. Due to what? Due to the automation of knowledge work. One should keep that in mind, automation of knowledge work. This is a core of Industry 4.0, I think. And like carrying cost, quality costs should be reduced between 20 and 50%. So tremendous threshold in terms of improvement that should be achieved by the concept. This is the promise. On the other hand, and this is what you see on the right upper side, is the reality. The reality reveals a big gap because, for example, 50% of the orders in a company in the average have more than one planned completion date, means replanning, rescheduling. So not a real-time business, but rather following the changes in a very long-term iterative manner. 57% of business use written documentation for inventory taking and transaction data. What does that mean? Again, far away from being real-time and adaptive. It takes a lot of time to enter the data, and the worse, in many cases, the data are not entered at all. So the information is just gone because of the big entrance barrier for data capturing. And in turn, 17% of our business do not use digital data capturing at all. So, I mean, this is not the majority, but it still shows that, for example, automated data capturing is not in use everywhere. And as one example, for one technology that can be used there is the RFID technology. This is in use with less than 5% of the company. So why is that? So we have a big gap between the promises on the one side and the day-to-day practice on the other side. Why is that so? High investment costs are the answers, combined with unclear economic benefits. Basically, in the dedicated case, because the big promises are made on the one side, but the companies or the decision makers ask, what does it mean to me or to my company? And there are uncertainties, and that creates a barrier. Another barrier is the necessary qualification of employees. So we have to enable our people to work with these tools to cope with a more decentralized decision-making process, etc. And finally, that was something that went on in the recent 5 years in Germany. Many companies were not sure, and the decision makers were not sure, is Industry 4.0 a real persisting trend, or is it sustainable, or is it just a hype? If one looks to the recent development, or first looks for what the companies are faced with, they are faced on the company level with big challenges. And among those, the biggest challenges are the accelerated reaction to customer demands, reduced time to work, and the increased flexibility. So, unfortunately, I lost presentation. Now it's back. Okay, I hope you see everything. So, what the companies have to cope with is a lot of variation and reaction on customer demands in a very short term. So that means flexibility and acceleration, normally some contradictions. Either you are fast or you are flexible. And the Industry 4.0 concept promises to build a bridge between them. So if one asks the companies, what they think if Industry 4.0 is on its way now. 50% meanwhile say yes, which is a quite high number, but still 33% say no, we don't see that it is on its way. And so the majority says yes, optimistic, but there are still a relevant part of companies not agreeing that the Industry 4.0 initiatives are really on their way now. So if one looks ahead and asks the companies, what do you expect for the future? And look to your own company and ask, do you think that you need to implement Industry 4.0? And then 34% of the companies say, yes, I fully agree. And 52% say, I somewhat agree. So they tend to say, yes, there will be Industry 4.0 will come, or we have to cope with it. So, and these two slides together show again kind of a tension. So saying, okay, not yet, but it will come to a certain extent. And all these figures, I think, represent a change that was initiated in the year 2012-13 by the Industry 4.0 initiatives, actually motivated by German government, Chancellor Merkel, and brought to the business day-to-day practice, meanwhile to a quite high extent, but still an ongoing process. So again, what are the obstacles on the way towards Industry 4.0? So what creates barriers and what may prevent companies from going the first steps? There are some deficits still to be handled. There's one thing, if you want to digitalize everything, all about the issue of data security becomes a crucial issue. And this is represented here. So IDC, the analysts from IDC asked the companies, and one of the major issues was data security. Actually, an issue that we experience or face in all digitalization initiatives, even when it comes to the implementation of a new ERP. There's a very high sensitivity towards this issue on the one hand. On the other hand, it's clear data get really fluid when you do digitalization, and so this has to be solved by the appropriate measures. Second thing, it's too expensive. There is actually many companies don't really know what it costs, but they hear about like sensors, software, technology that has to be bought, and they feel and think this is really too expensive, and too is relative to what you achieve. You are unsure what you get for your expenses. You easily say it's too expensive. So this is why I would like to give you some examples later on what one can do. Sometimes quite small things that bring you one step further towards Industry 4.0. So another thing is like lack of standards. For example, standard for the semantics between for the communication between machines. If you want to practice machine-to-machine communication, also is lacking. So we have a lot of, let's say, barriers in practice that have to be overcome if we want to really widely implement Industry 4.0. And here in Germany, we are working on, if you want to, on many of these issues in order to make steps forward. So now, talking a lot about Industry 4.0, it's probably good to understand what's the characteristic of Industry 4.0. So what comes with it, and I would like to give you an example for that. If you look to the Formula One racing cars, visualized in the right upper part. This is a system consisting of a person, the driver, and the technology, the car, in an environment, the racing course, where the car is, well, what's special about these cars? They are full of sensors, and they gather data for everything. The behavior of the gear, of the tires, of the brakes, etc. And they are connected, symbolized by in the middle, connected to the control center on the left. The data are gathered, the data are analyzed for any, if you want, so any technological domain in the car, in order to know what is the situation, in order to understand what happened and why it happened, and in order to predict what might happen. And so this is, if you see on what level these cars perform, this might be a very good picture for any company to say, okay, we want to get the Formula One car or racing team with a car that enables us to really perform at the limit, which these cars usually do. And what is necessary to do is actually to build and develop domain know-how through the evaluation of all available data. Really gathering all the data you can gather, analyze, understand, learn how to predict, and learn how to derive conclusions in terms of decision making. So, and that achieved by automation of data capturing, data processing, data analysis, and prediction, up to automation of decision making. Now, maybe you remember this one thing, big improvements in terms of rationalization by the automation of knowledge work. So that is, at the end, a core part of Industry 4.0 is automate decision making. So, what's the benefit for that? Quite easy. If you compare the Formula One, there's a lesson learned. A Formula One driver normally needs up to 20 rounds to get the limit to his best times for cruising a circle. But if you are able to analyze and to predict and to provide him guidance in terms of, in the right side, you can see that what's the optimum course, and project this, for example, into his helmet. With that support, this guideline, he gets to his limit within 3 rounds. So a tremendous optimization. And this is something what we have to project towards the business and production side in order to really get to the Industry 4.0 concept. So again, what we need to achieve when we want to get to Industry 4.0 is learn in terms of descriptive analytics, diagnostics, predictive, and then getting prescriptive, making suggestions in an automative data-based manner, making decisions what to do in the future. And if you summarize that, you get to a concept which is very well accepted here in Germany when it comes to manufacturing. And it describes the levels that, or the steps that you get through if you want to develop from, let's say, name it Industry 2 or 3.0 to Industry 4.0. So first level is transparent production system, really the comprehensive, automatic, and complete capturing of relevant data in order to achieve a digital shadow of your entire production system or company, knowing what's going on. And then this, you can name that level Industry 3.2 instead of 4.0. Then predictive production system, which allows forecasting. Industry 3.5. The controllable production system, and that means control in terms of real control circuits instead of the average-based planning logic of MRPs2, which never does optimization. This is represents Industry 3.8, and finally, and this is the goal of everything, the self-optimizing and adaptive production system, the so-called learning factory, which really not only makes automated decisions, but even adapt the decision-making procedures, learns according to better achievement of goals. And this is the Industry 4.0 where everybody is striving for. So now let me give some brief examples. With respect to time, I probably have to accelerate a little bit. Some future scenarios at the example, with the example or in the context of ERP, that might explain what or how one can achieve first steps towards Industry 4.0. So an example, what you see here, addresses odd management. So what you see is a scenario where, for example, iron parts are cutted, and normally you have some remaining parts which are not used to fulfill an order, and they get not really back to stock because the handling process to reinvent them to the stock is way too much effort to measure how long is the part or what's the size of the part, what quality it is, etc. pp. So it just gets put aside. What you do or what you can introduce in this case is kind of a laser scanner who measures the parts, the remaining parts, and feeds back these data directly to the ERP system. And if you combine that, for example, with a scanner like RFID or so, you can give these parts even identities. The system knows what part and what quality and what size went back to stock, and you can bring it into the next order process if it fits the specification. What you save basically is, first of all, you eliminate a lot of manual processing, like measuring, search, etc. And of course, you save material cost. Another example, what you can find here in Aachen, like 3 floors below me, in a manufacturing site, is the so-called real-time tracking of assembly orders. There's an assembly line. They build up like I don't know, like go-karts, small cars for private use in a manufacturing or in a manual assembly line. And what they do here is they track with a real-time location system. They track any order, any action, any part, any employee working there, any tool brought in a working process. And so by that, you have a very tight or dense information about any status in the production side. So this is automatic data capturing at its best. The sensors are, let's say, it costs money in an investment, but at the end, you achieve many benefits, like a reduction in process costs, elimination again of manual and partly automatic confirmations about order status, and you can tremendously reduce the error rate, because you can conclude, for example, if one part and a tool match in a manufacturing port which do not fit together, the system gives a warning to the assembly staff saying, okay, please change tool, for example. And if you go further with that, you can finally get to a system which is represented here, which is a controllable production system, actually representing a kind of teach-in mode for enterprise resource planning system. Normally, these software is, the parameters are set during implementation, and they stay there for the lifetime of the software. The benefit: no work for adjustment. The big deficit: you are always wrong with your plans. And this concept here is like from the track and trace, for example, achieved by RFID, the RTLS, etc., pp. You just start a production process with a very, very rough specification and let the system learn what are the steps, what is the sequence, what are the processing times, what are the transition times, etc., pp. Which material is used, and so on and so on. And on repetitions, the system learns the patterns, recognizes the patterns, and the routings are successively adapted to an optimal course of assembly process for as long as the new run is better with regard to the defined target system. So this teach-in mode at the end provides a significant reduction for the initial and ongoing planning expenses. It's directly feeding into planning efficiency, and finally makes your entire production way more efficient, working closer to an optimum. However, this is a thing that brings challenges toward our common mode to work. This procedure is completely against the planning philosophy, the centralized iterative planning philosophy of the most ERP systems based on ERP2 concept. And here a final example, and this is a well-known brand, Amazon, who are quite close to the Industry 4.0 concept when it comes to their disposition logic in shipping. The so-called anticipatory shipping is again, it is automation of disposition and decision making. Why? From the traffic on their web page, on the shop, where people just look to goods from a certain region, the system decides automatically which goods get shipped to which store or storage outlet center, just in order to achieve what? To tremendously reduce delivery time. Why? Because analysts figured out that the main buying criterion in online shopping is not the price, but rather the delivery time. If you're late before holidays, or you need a present for your family, it's more important that you get it in time than if it's a 5% reduction in price or so. So this is the most crucial issue when it comes to online shopping, and this is why they implemented the automated disposition and decision making towards shipment of goods among their stores. And this is, I think, it represents a very good example for this automated decision making. So now, let me give you a little impression about where we are here in Germany, or how we try to implement the Industry 4.0 concept on the one hand on the national level, but also on the company level. And as I said earlier, Industry 4.0 was introduced, you can say, by government, but of course not by government directly, but there were many, let's say, think tanks and companies heavily involved. Among those are like the ACATEC, the National Academy of Science and Engineering, DFKI, German Research Center for Artificial Intelligence, the Fraunhofer, and last but not least, the RWTH Aachen, and among those, the FIR, which is a well-known lab here in Germany, focusing on logistics management, etc. And many big brands like Bosch, Festo, SAP, Trumpf, etc., who worked on that concept right from the beginning. And that initiative led to, let's say, to a development. First of all, we had on the international level, we had two concepts, maybe different concepts. The one was IoT, basically Internet of Things, coming from the US, and the Industry 4.0 approach coming from Germany. The one heavily market-driven, IoT, and the other one more engineering-driven, Industry 4.0. And if you see the adoption to these concepts in Germany in 2016, companies were still kind of behind, not so optimistic that about the potential of digital manufacturing, because at the end they combined these concepts that Industry 4.0 is the industrial Internet of Things, IoT. So from 2016 to 2017, that was really a breakthrough. The companies really said, okay, we got it, we go for it. And so meanwhile, more than 62% of the companies really see the potential. And as you see, they are taking action on that. And how do they do that? Most of the companies in Germany do a quite decentralized approach. Each business unit decides separately how to move forward. While, for example, in China, the more centralized approaches are favored with 49%. In Germany, this is 39%. In Japan, this is only 12%. So what you can see is the companies are really starting. They are starting in a decentralized manner in Germany, and they're starting in a step-to-step approach. So the companies are really working along their way from the basic digitalization, like using computers, connect them, and then gaining visibility, data capturing, and trying to achieve that level. And from then, in the next step, get to understanding, analysis, prediction, and finally, self-optimizing routines or adaptability. And again, you cannot just jump from digitalization to adaptability. You have to go step by step, and this is what I name make the elephant edible, cut into slices. It is a huge concept, it is a very broad approach, and you probably cannot just skip steps in between. So, as I said, there are many companies working on the Industry 4.0 concept, and they are also learning what we need to achieve. And for example, when it comes to the established business software concept that you have in use, such as ERP, CRM, and so on, they have to finally get the data and provide a substantial part of this Industry 4.0, but many of these tools are at some part lacking or have to develop further. They need to be more open. We need more standardized interfaces to support the communication among the certain layers and actors in a supply chain. We have to implement more adaptive, role-based, and device-related user interfaces, because we need to take our people with us in this process. One thing is crucial, the ability to process big amounts of data real time. This is, for example, something which is in collision with many traditional ERP concepts. Forecasting on the basis of predictive analytics. So the concept of machine learning has to be introduced to this tool. Adaptive real-time planning and control instead of sequential MRP2 logic. Yeah. A decentralized process execution while ensuring higher transaction security. So close to the shop floor, deciding not in the central, in the control center or in the headquarter, if you want so. And finally, as a kind of integration layer and transport layer for data, the integration of cloud services into our software landscape. And when it comes to landscape, there are many decisions to be made. And just to give one example, if you talk about this established business software packages such as ERP or the MES, manufacturing execution systems, etc., pp., you have to really decide what your landscape in the future will be when it comes to Industry 4.0. There are different ways to Rome, we say here in Germany. So there is not the one best practice. It depends on the individual situation of any company. But just to give here an example for these architectural issues, on the left side, you see the combination of data acquisition and the shop floor, which is on one layer. On top of that, a smart production planning and control software, which bears the intelligence of the system. And finally, you have the ERP in the more traditional manner when it comes to order processing from order to delivery and let's say the commercial part of it. Yeah. On the other hand, you have ERP solutions that include, meanwhile, like advanced planning and scheduling routines instead of MRP2, etc., pp. And so there you have the option to say, okay, I want to have that upper level, the order processing and the manufacturing and logistics intelligence in one, combined with a data capturing layer in the shop floor. So these are at the end very crucial questions that any company has to decide with regard to its distinct situation. And there, of course, are many others, but they need to be done in order to have a guideline for a kind of roadmap, a step-by-step approach to Industry 4.0. And one lesson learned in many initiatives here in Germany is the concept of think big, start small. Since it is a very comprehensive, a huge approach that changes many things in day-to-day practice, we have to learn to adapt to the challenges and to the solutions. And a very good thing, what I think, is really to start with a pilot. For example, the examples that I gave on the shop floor may provide some ideas where to start with, and then from there, in a step-to-step approach, widen that concept, but having the big picture always in mind to give direction. So this is it from my side. Thanks a lot so far. I think there will be a chance for questions at the end of the session.
Thank you very much, Mr. Sontov. Birkaç slaytımız var. Ondan sonra soruları almaya başlayabiliriz. Zamanımız çok az kaldı. Ben Dr. Sontov'un değindiği birkaç konu üzerinde, özellikle Endüstri 4.0'ın şirketler üzerindeki algısı ile ilgili konuşmak istiyorum. Bu arada kendimi tanıtmaya atladım. Muharrem Gezer, Trovari Türkiye yöneticisiyim. Bizler şirketlerin Endüstri 4.0'a geçiş aşamalarında olgunluk seviyelerini ölçüyoruz. Biraz önce gördüğünüz 6 seviyeli Endüstri 4.0 geçişiyle ilgili dijitalleşme seviyesinden otonom tepkiye kadar olan süreçlerde şirketlerin mevcut durumu nedir? Bunları kaynak, bilgi sistemleri, organizasyon yapısı ve kültür boyutlarına değerlendirerek assessment yapıyoruz. Bir puan veriyoruz ve puanın sonucunda da aslında neler yapılması gerektiği, nerelerde eksikliklerin olduğu, bunların nasıl çözüleceği ya da kapanacağı konusunda yol haritalarını çıkartıyoruz. Eğer gerek duyulursa bir sonraki aşamada program ya da transformation dediğimiz uzun vadeli birlikte çalışarak firmanın belki sıfırdan Endüstri 4.0'a geçiş konusunda kılavuzluk yapıyoruz. Aynı zamanda akademi diye bir çalışmamız var. Bu çalışma firmalara 5 farklı pakette Endüstri 4.0'ın ne olduğu, biraz önce bahsedilen siber fiziksel sistemler, IoT, IIoT gibi, yapay zeka gibi şirket içerisinde nasıl kullanılması gerektiği gibi konularda eğitim faaliyetlerimiz var. Bunu akademi olarak adlandırıyoruz. 5 farklı seansta, her biri 4'er saat sürüyor. Genellikle 20 kişilik gruplar halinde şirketlerde yapıyoruz. Bilinçlendirme anlamında da çalışmalarımız var. Bu olgunluk seviyesi ölçme ile ilgili Akatek olgunluk seviyesi modelini kullanarak Endüstri 4.0 olgunluk merkezi ile ortak bir çalışmamız var Trovarit olarak. Burada portal üzerinden şirketlerin olgunluk seviyelerini soru ve cevaplarla uzmanlarımız tarafından yapılan değerlendirmelerle alıyoruz ve sonrasında da farklı boyutlarda, bir önceki söylediğim farklı boyutlarda olgunluk seviyesini ölçerek nerelerde farklılıklar var, eksiklikler var, onları raporluyoruz ve şirketin bir yol haritasını çıkartıyoruz. İşte hangi aşamalarda, hangi adımlarda, hangi zamanlarda neler yapılmalı gibi noktalarda bir yol haritası çıkıyor. Ben şimdi sözü Gülşah Hanım'a vereceğim. Sonrasında da soru cevap bölümüne geçeceğiz.
Merhaba tekrar. Bizleri takip edebileceğiniz birkaç bilgi aktarmak istiyorum size. Akademi bölümümüzde webinarlarımız 3 aylık periyotlar şeklinde ilan ediliyor. Bu webinarlarda konu önerilerinde de bulunabilirsiniz. Sizin gönderdiğiniz konuları da dikkate alarak bir içerik hazırlıyoruz. IT Matchmaker üzerinden webinarlar bölümünden webinarlarımız kayıt olup sonrasında takip edebilirsiniz. Download Center'ımızda yaptığımız çalışmalar ve Endüstri 4.0 ile ilgili, ERP yatırımları ile ilgili yeni yazılım geçişi olsun, işte ürünlerinizi nasıl konumlandırmanız gerektiği ile ilgili çok farklı detaylardan bakış açılarına sahip makalelerimize ulaşabilirsiniz. Trovarit web sitemizde blogumuz var. Bu blogda yine bizim yayınladığımız makalelerimiz oluyor. Aynı zamanda konuk blog yazarlarına da yer veriyoruz. Farklı bakış açılarına sahip değerlendirmeler okuyabiliyorsunuz. Sizler de eğer konuk yazar olmak istiyorsanız bize ulaşabilirsiniz. ERP Praxis bizim 2 yılda bir gerçekleştirdiğimiz Avrupa genelinde ERP deneyimi kullanıcı araştırması. Bu yıl yine Nisan-Mayıs gibi başlayacak bu çalışma. Sene sonunda da ERP'ler farklı boyutlarda değerlendirilmiş olacak, ERP çözümleri. Yeni bir yatırım yapmak istiyorsanız veya kullandığınız bir ERP programı varsa, bununla ilgili artıları, eksileri görmek istiyorsanız bu sonuçları da yine takip edebilirsiniz. Sosyal medya hesaplarımızdan da yine bize ulaşabilirsiniz, bizleri takip edebilirsiniz. Eğer sorularınız varsa şimdi almaya başlayabiliriz. Doktor Karsın ve Muharrem Bey seve seve yanıt verecektir sizlere.
So can I ask with the voice?
Sure.
As an industrial engineer, which skills we need to improve for the driving seat for the change industrial 4.0?
Mm-hmm.
So my question, which skill we need to improve that?
Sorry, I didn't get the question probably. So which
skills or talents we need to improve to seat driving seats for the change of Industry 4.0? Which skills or talents we need to improve?
Okay. Now I got it.
So I am an industrial engineer. As an industrial engineer, as you know, this is complicated because there are lots of information technology like writing code or something, etc.
Yeah.
So which skills or the talents we need to improve to seat driving to change Industry 4.0? Thank you.
Okay. This is a really good question. One can probably put the question more severe, saying, do we need rather guys from informatics and software development instead of the industrial engineers? Actually, me personally, I'm a mechanical engineer too. Yeah, and let's say 30 years ago, I never imagined to be so much involved in software issues. So I think really we need in the companies, we need skills who do understand the concept of, let's say, advanced analytics at the end. You need people who are able to analyze data. Data analysts, for example, in Germany, these guys, you can hardly find them in the job markets. They are a real bottleneck. So this is what you need. On the other hand, the question is how to get those people. And if you don't have them in terms of find them on the market, you probably need to also to further develop and educate your existing staff to better understand the concept of this, let's say, learning company. And I think these skills are more and more crucial. You have to combine at the end the knowledge about the software, artificial intelligence issues on the one hand, and the how to say that, for example, the engineering knowledge at the end, it still turns all around the engineering knowledge. This is the content where it is all about. It provides the principles, for example, for logistics disposition. You have to understand how to assemble a certain product. For example, you need to understand the product architecture, which is a very major parameter in it. And without this domain knowledge on the one hand, the knowledge about the let's say the data processing and analytics is nothing worth at all. So you have to have both competences and combine them in a company. But what we actually learn here in Germany right now is that the skills with respect to analytics, for example, are more the bottleneck because we do not have enough people working in that field. Does that answer your question?
I don't understand.
Did that answer your question?
Yes, yes.
Okay.
Thank you. Thank you very
You're
much.
welcome.
Başka sorusu olan var mıdır acaba? Cevaplamaya çalışalım.
Merhabalar, Tolga ben.
Buyurun Tolga Bey.
Daha çok Türkiye'deki durumu merak ediyorum. Şimdi bir değişiklik uygulamaya çalıştığımızda mutlaka bir dirençle karşılaşıyoruz ve Endüstri 4.0 konusu dünyada olduğu gibi Türkiye'de de son aylarda çok popüler hale geldi. Artık hani bakan seviyesinde de konuşmalara rastlayabiliyoruz bu konuyla ilgili. Ancak bir de bunun karşısında işte Endüstri 4.0 geldiği zaman bizim işlerimiz ne olacak, robotlar işlerimizi devrime alacak, biz ne yapacağız gibi soru işaretlerine de birçok insanın sahip olduğunu görüyoruz. Hani bu konuyla bu dirençle karşılaştığınızda nasıl cevap veriyorsunuz siz? Bu dönüşümün neler getireceğini nasıl açıklıyorsunuz insanlar, onu merak ediyorum.
Bunu ben mi cevaplayayım, Doktor Sontov'un mu soralım?
İkinizden de alabilirim, problem değil.
Şimdi haklısınız, çok büyük endişe var bu konuyla ilgili. Doktor Sontov da başlangıçta bir slaytında değindi. Bir belirsizlik var. Acaba ne olacak? Nasıl yapacağım? Nereden nasıl başlamalıyım? Kimle başlamalıyım? Yarın öbür gün ileride eğer bu dijital dönüşümü gerçekleştiremezsem rakiplerim beni geçecek mi? Yok mu olacağım? Gibi endişe var. Burada biraz aslında şöyle bakmak lazım. Önümüzdeki webinarın konusu aslında bu. Türkiye'deki Endüstri 4.0 yaklaşımı, Almanya ile karşılaştırma. Şöyle bakmak lazım. Yurt dışında olaya şöyle bakıyorlar. Diyorlar ki dijital dönüşüm ya da Endüstri 4.0 benim mevcut yaptığım işleri daha iyi yapmam anlamında evet olmalı ama bana yeni iş modelleri de sunmalı diye bir düşünce var. Şöyle açıklayayım. Evet ben otomasyonu yapabilirim, robotlarımı fabrikama koyabilirim, işimi daha iyi yapabilirim ama sonrası ne olacak? Sonrasında aslında ben bu veriyle, bu büyük veriyle, analitikle sadece şirket içinde değil, şirket dışında da yüzen, dolaşan veriyle yeni iş modelleri nasıl oluşturabilirim diye düşünüyorlar. E, Türkiye'deki bu endişe, kararsızlık, kaygı bazen de çok farklı ya da yanlış yatırımlara sebep oluyor. Genellikle şöyle düşünüyorlar. Makineden veri topladığım zaman ben Endüstri 4.0 gerçekleştirmiş olurum. Halbuki hiç öyle değil. Siz yukarıda bir izin kağıdını hala kağıt üzerinde yazıp imzalatıyorsanız aşağıda bütün makineleri dijitalleştirin, otomasyona geçin. Hiç önemli değil. Burada genele yaygın bir dijitalleşmeyi düşünmek lazım. Bence bizim gibi şirketler, sizin gibi şirketlerin dijitalleşme yolunda kılavuzluk yapabilecek seviyede. Biraz önce bahsettiğim olgunluk seviye endeksi ya da bir eğitim paketi aslında bilinçlendirmeniz anlamında daha faydalı olur diye düşünüyorum. İsterseniz daha sonra detayları konuşabiliriz. Daha detaylı bir şekilde.
Teşekkür ederim.
Rica ederim.
Merhabalar, ben Mustafa. Sesim geliyor mu acaba?
Evet Mustafa Bey, buyurun dinliyoruz.
Merhaba Muharrem Bey. Hello, Miss Dr. Carsten. Hello.
Yeah, hello.
Actually, so I can ask my question in English. That actually, I'm thinking that if the education system also should support such a new industrial level or not. What do you think about this? Thank you.
I definitely agree. Before I already said we need the skills, the company to implement such a concept. We need to modify the skill set in the companies. And where should the skills come from? The education system has to contribute to that skill set among our employees. And yes, so we have to educate our students and workers to be able to cope with that new technologies. And on the one hand, that addresses the conceptual competence to really to implement those concepts, but on the other hand, we have also our workers have to be able to work with it, with these tools, but also to accept it. And quite often we face, let's say, reluctance when it comes to these automation concepts. People think or feel controlled. They don't know what goes on because it's not that transparent to them anymore, because they don't do the manual steps. You can track by vision, for example, you see it. But if it's just somewhere in a black box, you don't know if you can trust to the results and so on and so on. So there are many levels where people have to be trained or better learn it right from the beginning in education. And so, yes, the education system has to contribute a major amount to these skills.
Okay, Dr. Santo, just quick question, one more.
Sure.
About Germany, let's make it a little bit specific. If we think about Germany, so how does it work? Does it start from the high school or university? Mentality.
Yeah. Well, actually, to some extent, it starts in the kindergarten. Yeah, but maybe a little kidding. But of course, we have these so-called digital natives. Children grow up with these digital devices in the private context. So maybe they don't have this a big acceptance barrier. What we experience with, let's say, like me, the mid-agers, for example, who were just before these digital natives. Yeah, I have to learn it, and I do, or I experience that sometimes as a kind of hard process. And I think our workforce has the same, or many of those have the same situation. But now, in terms of a systematic education towards this digitalization skills, it starts actually latest in high school, with dedicated courses when it comes to computerization, even simulation courses and stuff like that are offered. Maybe this is not obligatory. Not everybody has to join these courses, but more and more children or young people start to work on that. Even more girls. In Germany, it was like engineering things and so on. Informatics was a minced job traditionally. That changes a lot. And here, if I look to Aachen, it's a technical university, well known for the engineers, not that well known for the software people. Formally, these disciplines grow a lot, and they melt into the traditional engineering discipline. So here's no engineering course anymore which does not address software issues, simulation issues, and for also these things like data analytics and so on, get educated more and more as part of the traditional engineering education.
Mm-hmm. So it's like something mixed together now ongoing.
Yeah. It's interdisciplinary, if you want so.
Right.
So it is not in order also to get this combination between the domain knowledge of the engineering, at the different engineering segments. It's a very wide field on the one hand, and the basic skills of, let's say, working and understanding the concept of analytics, for example.
Thank you.
Müsaade ederseniz bu konuyla ilgili benim de bir iki yorumum olacak.
Tabii Muharrem Bey. Teşekkür ederim.
Öncelikle bu şirket içindeki yetkinlikler konusunda maalesef şirket içerisindeki kişiler, yöneticiler ya da çalışanların tamamı sosyal medya üzerinden, internet üzerinden, bir takım sektörel dergi üzerinden Endüstri 4.0 ve dijitalleşme konusunda bilgi sahibi oluyorlar. Ama bunlar daha çok, bu bilgiler daha çok hani gerçekte ne olması gerektiği yerine fütüristik yaklaşımlarla sunuluyor. İşte robotlar gün gelecek sizin işinizi elinizden alacak. İşte ileride yapay zeka şu sorunlara cevap verecek. Böyle bir fütüristik bilinçle gittiği zaman şirketler ya da şirket yöneticileri böyle bir fikri aldığı zaman fabrika çalışanlarından Endüstri 4.0'a adım atılması konusunda çok hızlı hareket ediyorlar ve yanlışlıklara sebep oluyor. Bunu aslında şirket bünyesi içerisinde bu eğitimin Endüstri 4.0 ne olduğunu ya da ne olmadığının verilmesi gerekiyor ki tek bir bilinç, ortak bir bilinç ortaya çıksın. İkinci dediğimiz konuda da eğitim konusunda da Türkiye'de şu anda üniversitelerin sertifika programları var. Bilmiyorum takip ediyor musunuz? Hatta Bahçeşehir Üniversitesi'nde yakın dönemde bir lisans programı açıldı. Orada da artık Endüstri 4.0 mühendisi yetiştirilmeye başlandı. Bir de son bu çocuklara, küçük çocuklara ilkokuldan kodlama dersi veriyorlar. Belki duymuşsunuzdur. Evet. Ben bunu çok tasvip etmiyorum. Kodlama dersi verilmeli ama bu çocukların ileride kodlamayı meslek sahibi olmaları gibi bir beklentiyse bu, veliler açısından söylüyorum ya da okul yöneticileri açısından söylüyorum. Bu çok doğru bir şey değil. Çünkü eğer teknoloji böyle giderse ileride yapay zeka tarafında belki kodlamaya da gerek kalmayacak. Bence bu öğrencilerimiz ya da çocuklarımız analist olarak yetiştirilmeli, mühendis olarak yetiştirilmeli ki zaten kodcuyu her yerde bulursunuz. Bugün Hindistan'a gidin, çok düşük rakamlarla istediğiniz programları yazdırabiliyorsunuz. Önemli olan buradaki inovasyon, yeni fikirleri ortaya çıkarma, bu fikirlerin arkasından gitme gibi çocuklarımıza eğitim vermeliyiz diye düşünüyorum.
Çok teşekkür ederim cevaplarınız için.
Teşekkür ederim Mustafa Bey.
Can I ask a quick question?
Buyurun.
when you want to improve some system, the first question of the management is return of investment. In how many years or how many months the return of this investment will be. So it's sure that related with the maturity level of the company, but you have worked with several companies, I think, and can you give a year range that these investments are returned? How many years? In how many years?
Mm. Well, actually, it's really hard to say or to give an answer with which is valid in general. Why? Because that always depends on the dedicated situation in that company and the scope, for example, of the project. If you, I would not be able to give any ROI period for if you say the complete Industry 4.0 concept. But if you, this is why I say make the elephant eatable, cut it into slices. If you start with these more focused projects, it is way more easy to first of all oversee and predict the cost that you have to face to implement that, and it is way more easy, and especially when it comes, for example, to this shop floor related things like data capturing, etc. You can way more easy calculate also the benefit, the profit, and sometimes you have very short return on investment rates way below 1 year. But when it comes to the if a company is just starting with that concept and you ask what's the return of predictability, or in general for the entire manufacturing system, you normally are not able to give a sound answer to the ROI, because you have so many parameters in there that at least if you mean it serious, I mean, you can calculate everything, and if you say, I wish this or that result, just let me know, I can calculate. But this is probably not what we want to know. We want really to know, we want to be safe about our answer. So I'd say take the smaller projects, modules, and go step by step, and then you can answer these questions, and you quite often have a real good ROI, which motivates management to go. And my experience here in Germany is, if you just get started and you achieve the first benefits, that raises the motivation to go for wider concepts, to make bigger steps. Yeah, in the beginning, it is probably one part of it is just learning and to understand and to get more trusted in that concept. So yeah, this is actually what I can say. I cannot give really a valid answer to ROI. I think that was not really serious. Okay.
Yeah, thank you. Yeah, when you are talking about software projects, if you increase the productivity in the shop floor, then you can say now we are manufacturing with 100%, then we will with 90% and product this with the person
percent, yeah.
Cost. Yeah. It's easy to calculate. Right. But when you are talking about something that is, for example, made by one person, and you can say that it normally costs 8 hours, but now he can calculate this in 1 hour. Then can we go without this person? No. So the return of investment is how can you answer such kind of questions?
You're right. If you cannot, let's say, if you automate part of the, for example, disposition making or so, decision making part in the logistics, and but you cannot. I mean, people costs are not variable to 100%. As you said, if it's below one full job, you cannot say, okay, I save that because I still need the guy. And in this case, you have to be fair and say, okay, it is not the reduction of the people costs unless you can this stuff can work in other fields and be productive in this field. So then you cannot put that to the ROI in terms of return. This is true. And if you cannot argument, for example, stock reduction due to shorter processing times or stuff like that, and coming with it reduction of capital costs or so, then you get in trouble with an ROI consideration. This is true. But on the other hand, what we face here in Germany, where you have a normally quite high level of optimization in the companies, the optimization level raises more towards the disposition, to the decision-making level, and the benefits normally are like shorter processing times, reduction of stock, etc., pp. And you start to calculate on that level. Yeah. Of course, this is not that direct as if you just calculate in the, let's say, the first level rationalization, which means like cutting of head cost. Yeah? So, and then the judgment or the argumentation or giving reasons for such an investment gets more difficult. It's a higher challenge. That's true.
Yeah, thank you very much.
Yeah.
Tolga Bey, ben birkaç cümle söylemek istiyorum bu konuyla ilgili, müsaade ederseniz. Şimdi biraz önce Dr. Sontov'un da söylediği gibi ROI'nin hesaplanması gerçekten çok zor ama yapılan, ki Almanya'da da aynı şey yapılıyor. Biz Türkiye'de de firmalara bunu öneriyoruz. Bunu bütün bir şirket geneline yaymaktan ziyade küçük bir başlangıç olarak POC dediğimiz bir çalışmayla sadece bir bandı ya da bir üretim alanını dijitalleşmeyi arttırarak en azından neler elde ettiğinizi bir görün. Bu birincisi ne kadarlık bir maliyet var, ne kadarlık bir efor gerekiyor, artı başarıyı elde ettiğiniz zaman da motivasyonu gerçekleştiriyorsunuz. Şimdi bu ROI'nin hesaplanmasında bir takım makro değerler üzerinden gitmekte fayda var. Ben bir McKinsey'nin yaptığı bir dijitalleşme araştırmasından örnekler vererek belirtmek isterim. Örneğin minimum %3'lük bir produktivite, yani verimlilik, üretim verimliliği artışı gerçekleşiyor. Minimum. Minimum %10 bakım maliyetlerinde iyileşme gerçekleşiyor. Minimum %30 herhangi bir duruştan dolayı verimsizlik kaybı engelleniyor. Minimum %10 kalite artışından dolayı bir fayda var. Dolayısıyla bu genel, tabii ki biraz önce söylediğim rakamlar firmanın iş alanına göre makro seviyedeki değerler üzerinden bir KPI tanımı yapılarak bu biraz önce söylediğimiz daha kısıtlı bir yerden giriş yapıp bunun sonuçlarına göre değerlendirmek daha mantıklı olacaktır.
Anladım. Çok teşekkür ederim.
Rica ederim.
Teşekkür ederiz. Dr. Santov, thank you so much.
Thank you.
Ben de çok teşekkür ederim katılımınız için. Gülşah Hanım'ın belirttiği gibi önümüzdeki dönemlerde webinar serisine devam edeceğiz. Lütfen takip ediniz. Çok teşekkür ederiz katılımınız için.
İyi çalışmalar diliyoruz hepinize.
Çok teşekkürler, iyi günler, kolay gelsin.
Biz teşekkür ederiz sizlere de.
Thank you, Mr. Sontov.
Yeah, thank you, everybody. Thanks a lot.